So our aim of the experiment was to see what happens with the current and voltage in series and parallel circuits when adding more bulbs. So we did the series part where we had the circuit and then we connected the bulbs in like that. So the 3 bulbs next to each other. And just to remind you how that looked, in terms of our circuit, we had our bulbs connected in like this with our springs so that we can then measure across each of them like that. So this time we're going to be doing a parallel circuit. So parallel circuits are slightly different in the sense that if we go back to our sketch over here, you will see that as the current comes through to here, it'll split off into two stages. And then we would have a light bulb in each of these. And here it would split off into 3. So doing this with just cables is really, really difficult. So doing it with just these, we're going to end up with an absolute mess of cables and it's going to be really hard. So I have these little copper connectors over here that we connect with a spring like this, so that when we add in our light bulbs into the spring, it's just easy to add in the light bulbs like that. So I'm just going to do that. I'm bending one end upwards just slightly so that we can connect things in easily. Okay, so let me just do that. Okay, so there we have our spring connecting these 3 things. Okay, for the people who weren't here last time, we are busy. We are halfway through an experiment over here where, well, let me just read through it again. Our aim with the experiment is to see what happens with the current and the voltage in series and parallel circuits when we add more bulbs. So the idea is to just figure out what's going on with the current and voltage. So we've got some bulb and bulb holders, we've got a battery, we've got connecting wires, and we've got a multimeter, which is this thing over here. Okay. So last time we connected the series part of it. This time we're going to be doing the parallel part of it. So last time we measured the current through the main circuit as well as through each the current through the main circuit, and then we measured the voltage across the battery and across the bulbs. This is what we saw. If we had 1 bulb, then our voltage across the battery, which was 2.85, voltage across the bulbs was 2.4, and our current was 140 milliamps. With 2 bulbs, we could see that our voltage was sort of roughly split over the 2 bulbs. And with 3 bulbs, we could see that our voltage was split roughly over the 3 bulbs, like that. And our current steadily decreased. So then there was a few questions. What did you notice about the voltage? It tended to stay the same. The voltage across the battery stayed the same over the 3 experiments. So the current through the circuit, the amount of current decreased as you added more bulbs. So then what did you notice about the voltage across the bulbs? So the voltage across the light bulbs were the same between the light bulbs in each circuit, more or less. Here we have a slight difference, here we have a slight difference. It's not enough to actually matter. But our voltage across the battery was sort of evenly divided across these. Okay, so now we're going to be doing the parallel circuits. So we're going to be measuring the voltage across the battery, the voltage across each of the bulbs, the current through the main circuit, and the current through each of the bulbs. So this is going to be a slightly more difficult experiment. Okay, we have a question that says, why did the current decrease across over here? So let me put it in this way. This is a highway that you are traveling down in your car. And each of the bulbs is sort of like a traffic jam. So the more traffic jams you put in the highway, the less cars can travel through the highway. So your current is essentially sort of the amount of cars that can travel through the highway. So the more bulbs we added, the more time it took for each one to go through. So the less cars, the less current can essentially go through the whole circuit. So that is an explanation for why it decreases. Yeah. The voltage across the battery stayed the same because our battery is essentially how much power we have to work with. So here we would have, essentially this is the amount of strength each of our little currents have to do things. So as it went across the bulbs, here they used half of their strength across each of the bulbs. Here they used a third of their strength across each of the bulbs. But they only had this much strength to start with. So yeah, let's start with our parallel circuit. So first we're going to connect in just the one bulb. So here we go. Here is our circuit. I've connected the battery to two little springs. That will make it slightly easier for us to connect things to it. And now we're going to connect in just the one bulb. So here we have one bulb, and let's take some wires. So we have a wire coming from here to over here, and another wire coming from this end of the bulb to this end over here. And our light bulbs lights up, so we know that it's working. So the first thing we want to do is we want to measure the current through the main circuit, but our current needs to be measured in the main circuit. If we recall from our sketch, the ammeter is placed in the circuit itself. So now I'm going to turn this on, and I'm going to turn it to the ammeter side over here. And we want it to be there because we're measuring that. If you have the wrong measure, then it will just show you zeros or a -1. So here we can see that it'll be in mirror image for you guys. So it says 148 amps. If we have the wrong setting, for example, it'll just show a 1 with a dot like that. So there we go. Our first measurement is 146, more or less 145.6 now. Okay, 146 amps. So let's disconnect it so that our light bulb stays nice and neat. And now we're going to go fill this in. So our current through the main circuit over here was 148 milliamps. Okay. So now we're going to measure the current through the bulbs. And since we only have one branch, it'll be the same. So we have here 148 milliamps. Now we're going to be measuring the voltage across the bulbs and the voltage across the battery. So let's go back to over here. We're disconnecting our ammeter. I'm going to leave these two wires connected like that so that it'll be easier to take them apart and connect the ammeter back in. So now I'm going to take my multimeter and I'm going to turn it to the voltage side, which is on the other side. And we want that setting. Angled. Okay, let's go measure our voltage across the battery, which is just from here. So we can put these two parts over there. Come on. There we go. Okay, we can just stick them in there and then we should get a nice clear reading. So we have minus 2.86. That minus just tells us that the direction is in the opposite direction that the multimeter normally measures in. So we have 2.86 volts. So let's go back to our experiment here. So our voltage across the battery is 2.86 volts. Now let's go look at our voltage across the bulbs. So we're going to take these two measuring points out, and now we're going to stick them over here across the bulb. So there and there. And we have 2.4 volts. Back to here. Here we have 2.4 volts. Okay. There's a question that came through that says, what does the multimeter do? So normally, let me just disconnect this so it doesn't burn the whole time. Normally, you can get an ammeter and a voltmeter separately. So what a multimeter does is it measures both the amps and the volts. So it has a bunch of settings all around the sides here. So it says over here DCV, that is direct current voltage. Direct current is like we get from batteries. If it says ACV, then it's alternating current voltage, which is electricity that comes from the mains in our house. There, the current alternates the whole time. So here we have ACV over there. Here we have DCA, so that is our current through a direct current amperage. So this will mean we measure the current through a circuit that is powered by a battery. And it's got a bunch of different settings. So here, over there, is a AC current. So this setting right here is what we'll use to measure the current through the main circuit. That little symbol over there is a diode symbol. Let me see if it'll focus a little better. Not very. Okay, that is a diode symbol. So that is what you would use to measure things like LEDs, light emitting diodes. So that is something completely different, and we don't use that at all for now. And over here, we have a little ohm symbol over there. That says that we are measuring the resistance. So the resistance is essentially how much power each of our elements in a circuit uses. So we're not going to be using that now, but you will probably be using that at some point during high school. So for now, we are concentrating on this side here and this side here. The settings I am using is on the current side, I'm using the 200 milliamp setting, and on the volt side, I'm using the 20 volt setting. Okay, so let's continue. We have taken all of the measurements for our single bulb circuit. So now we need to add in multiple bulbs. So for this, I'm going to be using these. I'm going to be taking this bulb one out. So this is our parallel circuit essentially already built, but slightly differently. So I'm hooking it onto that little pointed end on that side. And now I'm going to be inserting another one on this side that I can connect this to over there. So now, disconnect this bulb. So for our single circuit, we're just going to insert our bulb there, add another little spring here, and then we can use one of these to connect it over here. And the reason why we want to do that is because we are going to be measuring the current going through these over here. Let me just disconnect it so that it's not burning. So now for our second bulb, we're going to do the same thing. There we go. Placed in over here. So there's our bulb there. And when we put in our third bulb, we're going to be doing the same thing. I know this is a little confusing at the moment. So now, if we want to connect in two bulbs, all we have to do is grab two wires and then connect in like that. So now we have two bulbs connected. So if I connect there, you'll see that only the first 2 bulbs are shining. And if I take another wire and connect in the 3rd one, then you'll see that our 3rd bulb will be shining. So there we go. So this is how our circuit is going to work. And I'm just using these copper connecting pieces in order to make that happen. So that was our first bulb. This is now our second. So now we need to go take all of our measurements again. This time we're going to be taking the measurement for voltage across the battery and then across each of our light bulbs. So we're going to be putting our measuring things over there each time. And we're going to be measuring our current in our main circuit, which means we're going to be inserting it here. And we're going to be inserting it into these wires in each of our light bulbs. Okay, so let's start. Let's start with our voltage. So let's first measure all of the voltages. So let's connect our circuit so that our light bulbs are glowing. So voltage across the battery. Stick these in over there. And that gives us 2.73 volts. So we go to over here. For 2 volts, our voltage across the battery is 2.73 volts. Now we're going to measure it across the bulbs. So we're back to here. Take these out there. And now we can place them there and there. And that will give us the voltage here. Come on. There we go. Okay, I get 2.1 volts. And for our other bulb, let's just measure it. Here, I get 2.05 volts. Okay, let's go write that in. So for our first bulb, we got 2.1 volts. And for our second bulb, we got 2.05 volts. Okay, now we're going to be measuring our current. I think it's because we are above 200 milliamps. So that means I need to take this out and put it in here because this has a, there we go. Now we're getting a measurement. Okay, so we have 270 milliamps. There we go. Troubleshooting. So our current through our main circuit over here is 270 milliamps. My apologies for taking so long to figure out what's going on. So now we need to take our current through the bulbs. So I'm going to disconnect this. Our bulbs are still glowing. And now I'm going to connect it into here. So there's our one side. And here's our other. There we go. It's connected in. So now we can see it's 130 milliamps. Okay. So our first one is 150 milliamps. And our second one, disconnect that. Connect this one back in. Disconnect this one. Connect this back in. Okay, both bulbs are shining. So now we have 0.14. So that is 140 milliamps. Here we have 140. Come on. 140 milliamps. Okay. Our lesson is almost over because I was spending most of the time troubleshooting. So let's see if I can do the rest of this very, very quickly. So disconnect this and this. Now we need to add in one more wire over here. There we go. Now we have 3 bulbs. So let's first go measure our voltage. Okay. So measuring our voltage. So first across the battery, which gives us 2.48. So here we have 2.48 volts. And now we are going to measure it across each of our light bulbs. So here we have 1.85. Here we have, come on, apparently nothing. Come on. Okay, there we still have 1.85. Let's see if we can get this one right now. Okay, 1.78, no. 1.82, okay. Here. Being remarkably erratic. 1.70, okay. So we had 1.85 volts. We had 1.82 volts, and we had 1.70 volts. Okay, now for our current. Okay, our time is up, but I'm gonna quickly continue this experiment because we still have 3 minutes before we get kicked out. So I just want to get these measurements, and then next time I will answer the questions based upon the measurements. Okay, so let's quickly get these measurements. So our current through the main circuit, again, we have to do this. Okay. Okay, there we go. Is 0.4, so that will be 400 milliamps. 400 milliamps. Okay. Now back to over here. And we can disconnect it here. And now we need to connect it into each of these. So first one, there we go. There we go. We get 0.13 milliamps. Second one, disconnect that, put this back. Second one, we get 0.13. And our third one, we get 0.13. Okay, that makes it easy. Okay, the whole circuit has just decided to fall apart. Lovely. At least we got our measurements quickly. Okay, so back to here. We have 130 milliamps, and again, 130 milliamps, and 130 milliamps. Okay. So, we have almost no time left. We're going to be kicked out. So next time I will take a look at these values. We will draw some conclusions and we will answer some questions. Okay,